So did you notice something interesting to the results we received to yesterday's HVAC problem? We basically got 3 different results. Which one is correct? Technically, they're all correct, and technically, they're all wrong. So let's take a look as to why. First, let's look at the problem that was posed yesterday. So the question was, how many BTUs does it take to raise 5,000 CFM of air from 12 degrees Fahrenheit to 80 degrees Fahrenheit? So to answer this question, we're going to use the very popular sensible heat equation, QS, which is BTUs of sensible heat, equals 1.08, which is called the convenience factor. We're going to talk about this in a minute, times CFM times delta T. We know the 1.08. The CFM is 5,000, as noted earlier, and the delta T is 80 minus 12, which is 68. So when you plug that in, you get 367,200 BTUs. Okay, so this was the most common answer we received yesterday. This answer will primarily depend on which convenience factor you use here. So the most popular one we received was 1.08. There are other very popular convenience factors. If you're like me and you've been around a while, I grew up on 1.085 as a convenience factor, which gives us 368,900 BTUs. And some folks today are using 1.1 as this convenience factor, which results in 374,000 BTUs. Okay, so let's talk about this convenience factor. This is actually very important to understand. So this number comes from the density of air times the specific heat of air times 60 minutes per hour. So at standard air conditions, which is defined as 70 degrees dry air at sea level, if you multiply that by the specific heat of air times 60, you'll get 1.085, which some people shorten to 1.08, and some folks use round up to 1.1. So that's at standard air conditions, sea level, 70 degrees. So this will change greatly depending on where you're located. So if you're at sea level, great. If you're in Breckenridge, Colorado at 12,000 feet, you can get into big trouble if you use this convenience factor. So please pay attention to that. For most normal, everyday air conditioning situations, 1.08 will work just fine unless you're at very extreme elevation or very extreme temperature, which is a whole other issue in and of itself. So if we go back to the answers we got yesterday, which one is correct? Well, technically they all are, depending on what convenience factor you used. And technically they're all wrong, because if we look at actually our elevation here, which is about 2,000 feet, and the temperature of air, which was 12 degrees yesterday, this equation really isn't 100% accurate, or this convenience factor isn't applicable to this area. Now, the differences are very small, so it won't really matter that much, as we stated. So any of these answers are acceptable. The 1.08 was the most common convenience factor used, so this was the most common answer. And thank you so much for watching. We appreciate it.